So this chart is pretty useful, but this chart has limitations. What limitations? All the values here are integers, are whole numbers, whole numbers. So we know that if value is one standard deviation above the mean, so we would know that between that value and the mean, you have 34.13% of all cases. Now I'll ask you this question. What if its value is not quite one standard deviation from the mean? It's a 0.6 standard deviation from the mean. If you have a value here, let's say if you have a value somewhere here, 0.6 standard deviation from the mean. What is that percentage? What is that percentage? You know, from here to here is 34.13. What about if you have a value 1.5 standard deviation from the mean? 1.5 is right here. So within this interval, from here to the mean, what is that percentage? Well, this chart does not give us that information. What do? We use a better chart. We use a better chart, a table. Use a table. Here is a normal distribution table. This is a normal table that contains z-scores. Yeah. Okay. Contain z-scores. Let me going out to make this. Okay, let's do this. Okay. Make the table smaller so you can see everything here. Okay. This normal distribution has the first column that tells you z-score. The z-score is like on this chart. We have a z-score here at the bottom. Z-score at the bottom. And also on this table, you have percentages here. Percentage here, and this value are percentages. Like this chart, you have a percentage here. So you have this z-score and the corresponding percentage. In this table, you have the same thing. You have a z-score and the corresponding percentages here. Now let's see how do we use this table. Let's first find something that we already know. We know that the one standard deviation above the mean, within this interval, you have 34.13% of all cases. Now let's go to that table to find a 1. Z-score 1, and read across, you find 34.13. 34.13. Let's see how the table is made. This table is made by showing the percentage from the mean up to a particular z-score. See, in this little picture, in the middle is the mean, and this is up to a particular z-score. It's like within this chart is the mean in the middle, up to a certain z-score here. Okay. So from the mean up to a z-score, this z-score you can find them here. Okay. If this z-score is 1, if this z-score is 1, that's why you find 34.13. So this is a shaded area. If this z-score is 1, this shaded area will be 34.13. That means 34.13% here. Okay. But if this z-score is 2, let's go to 2. What is 2 here? If the z-score, if that z-score is 2, 47.72%. That would correspond to here, from 0 to 2, 47.72%. Okay. Well, let's go back to our first question. What if we have a 0.6 standard deviation here, 1.5 standard deviation here? This question cannot be answered by looking at this chart, but it can be answered by looking at the table. Now, 0.5, 0.6, if this z-score is 0.6, let's go to 0.6. You read across 22.57%. So that slice will be 22.57, 57%. Okay. Now, what if this z-score is 1.6? 1.6, then that percentage would be 44.52. So this area would be 54.52%. Okay. What about this? What about here? What about -2? -2. And 2 standard deviation below the mean, we know that there should be 47.72%. Can you find that out in the normal table? No, we cannot find that directly. The normal distribution table only shows the positive side to save space. But we know that a normal distribution is a symmetrical distribution. You know the positive side, you should also know the negative side. Now, when you have a z-score -2, you just go to look for the positive 2. 47.72%. If this z-score is positive 2, this should be 47.72. If it's -2, you should have this slice. So if this slice is 47.72%, this slice bound between 0 and -2 should also be 47.72%. So you just go to the positive side, looking for the percentage that corresponds to a negative z-score. That should work in the same way. Now, another advantage of using this normal distribution table is that it gives you more decimal places. Not just 0.5, 1.2 something. It gives you 1.25, 1.69, so on and so forth. For high decimal, for more decimal places, you can just see there's this first row. They give you the second decimal places. If you find the percentage that corresponds to 1.09, where do you go? You first go 1.0, then you read across until you hit the column with heading 0.09. So this percentage should be a percentage that corresponds to z-score 1.09. So that is, if this z-score is 1.09, this slice, the size of this slice should be 36.21%. Okay, so this normal distribution table is much more useful than this chart. Okay, now let's do a couple of practices how to use this table to help us to do some calculations. And this question, let's first look at this question. What percentage of cases has a score? Okay, let me first take off this so that we kind of understand the context here. Between what two scores do the middle 95? Okay, we already did this question. Let's move on to the next question. Okay, there's a little confusion involved. Okay, here, this question. A score is 86.3. What percentage of observations lie between the mean and 86.3%? The normal distribution is the same. 78 is the mean and 6.3 is the standard deviation. But for this distribution, there's one score here, 86.3. 86.3. This question asks, what percentage of observations lie between the mean and the 86.3? So that is, what is the size of this slice here? What is the size of this slice? What we need to do is to figure out 86.3 is how many standard deviation above the mean. How many standard deviation above the mean? 86.3 is how many standard deviation above the mean. This is the formula we use. Remember we calculate z-score. This is a z-score formula we use to convert a value of variable x into a z-score. You plug in the actual values, particular value of x, followed by the mean divided by the standard deviation. So we know 86.3 is 1.32 standard deviation above the mean. It's positive, so it's above the mean. 1.32 standard deviation above the mean. Okay, 1.32 standard deviation above the mean, that corresponds to what percentage? What is this percentage here? Let's go to the normal table. 1.32, 1.32, 1.32, 1.32, 40.66%, 40.66%. In other words, come back to the question. This slice should be 40.66%. So that's how we answer this question. 40.66%. I have another question. A score is 60. What percentage of cases lies below this value? In other words, here in this distribution, the mean is here, and we have a 60. Obviously 60 is smaller than 78. It's below the mean, so we have 60. But this question asks, what percentage of cases lies below this value? In other words, what is the size of this corner? What is the size of this corner? 1% appear to be very small corner. 2%, okay? To answer this question, we first have to figure out what is the percentage of cases that lie in this area, okay? To find out that answer, you need to convert. You need to decide 60 is how many standard deviation below the mean. 60 is how many standard deviation below the mean. What do? Use the z-score formula again. Z-score formula here, we convert this particular value 60 into a z-score. 60 minus 78 divided by 6.3 give us negative 2.86. So 60 is 2.86 standard deviation below the mean. Now let's go to the normal table. 2.86, 2.86, 2.86 is right here. Okay, that's because that heading with 0.06. 2.86, 2.86, 49.79, 49.79. Okay, let's come back. Okay, 49.79, 49.79. So we see the percentage that corresponds to 2.86 is 49.79. So if that corner is 49.79, that's impossible. We say that the way the table is made here, that shows the percentage between the mean up to a certain z-score. So now we're on the negative side. Negative 2.86 should be correspond to somewhere here. So the percentage should be from the mean up to this z-score, negative 2.86. So those percentages refer to the area from the mean up to a certain z-score. Does not refer to the size of the corner. But our question is about the size of the corner. So the 49.97% is not the size of the corner, but this area. 49.79% is this area. To find the size of the corner, you have to do a little bit more maneuvering. 50% minus 49.79%, and that gives you 0.21%. That is the size of the corner. One more question. In a normal distribution such as this, okay, We know that the percentage, we have a percentage here, 42%. From the mean to a particular value of the variable is 42%. We like to know what is this x2? What is the value of x2? How do we find out this value? Okay. How do we calculate this x value? Okay, 42% here from the mean up to this point is 42%. Now let's think about in a standard normal distribution, in a z distribution. Let's see, in a standard normal distribution, if we have the mean here in the middle up to a z-score, if we have 42% here, we can find z-score by reading the normal table backwards. Now, what is the usefulness to find out this z-score? It is useful because if you want to find out the value of x here in this distribution, you need this z-score, because see this formula here. Remember this formula? This formula is a z-score formula we use to calculate the z-score. But you can change the term, change the size of a variable in this formula to derive at this new formula. With the new formula, this expression is the value of x can be expressed as a function of the mean of the population, and the z-score, corresponding z-score, correspond to this z-score, and the standard deviation. We know the mean, we know the standard deviation. All we need to know within this equation is what is the corresponding z-score. What z-score corresponds to this value of x? So we need to figure out what z-score corresponds to this x. This x is upper bound between the mean and this value that contains 42% of all cases. So what we need to do is go to the normal table to find a z-score between this z-score and the mean. There are 42% of all values. Now let's do it. We just need to go to the normal table to read the normal table backwards. Okay, now in these percentages, we need to find a value 42%. Here is 4192, 4207. You don't have exactly 42%. So you can, 42 is somewhere in between. We don't know what that is. We don't know where that is. So we just use either one of them. We can use 4192, then we'll find the corresponding z-score. Or we can use 4207. I decided to use 4207. If we decide to use 4207, the corresponding z-score would be 1.41. With 1.41. So let's use 1.41 z-score. Come back in that formula, plug in the actual value. This is our formula here. First term is the mean, and this is z-score 1.41 times standard deviation. You complete the calculation, you obtain a value. That value should be this value, 86.88. So there's a simple way to check your results. 86.88 is a value larger than the mean, above the mean. So you know that its number possibly is correct. Okay. So we discussed the probability distribution, especially normal distribution. Now with this normal table, you can do all kinds of meaningful and interesting calculations. And now you can go to in-class activity number 9 to practice those calculations. Then you can go ahead to do the assignment number 9 as well. I hope this helps. See you next time. Goodbye.